Welcome to this explainer. Today, we're taking an absolutely massive cinematic journey, literally tracing raw energy from the fiery core of the sun directly into your living room. We're talking about the photovoltaic path and how we actually convert sunlight into power. Because when you stop and think about it, it all starts with one fascinating question, right? How does a single beam of sunlight power your entire home? Let's dive in and solve this incredible scientific mystery.
Okay, let's mop this out. We're going to look at number 1, the photon's journey. 2, inside the photovoltaic cell. 3, creating the electron flow. 4, inverters DC to AC. And finally 5, powering homes and grids.
So, part 1, the photon's journey. Here is the overarching roadmap of this complex process. Basically, the sun emits photons. Those photons strike photovoltaic cells. Electrons start flowing as DC. An inverter converts that DC to AC, and boom, power flows out to the grid. But what are photons exactly? Well, they're these tiny, microscopic packets of solar energy. Just imagine them hurtling through space from the sun, eventually crashing right into the dark, highly engineered surfaces of rooftop panels. Which brings us to part 2, inside the photovoltaic cell. Let's zoom in microscopically here. The solar cell is our primary catalyst. It's the specific photovoltaic component designed to capture that sunlight and actually convert it into electricity, rather than just letting it dissipate as heat. And it pulls this off because these cells are built from a semiconductor material. Usually we're talking about highly purified silicon. Its very atomic structure is practically waiting to interact directly with that incoming sunlight. All right, part 3, creating the electron flow. Now, what's really interesting here is what happens next. Hidden within that semiconductor are electrons. When those incoming photons strike, it's kind of like a microscopic game of billiards. They transfer their energy, knocking these subatomic particles completely loose and hurting them into a highly organized flow. And there it is. That capture of sunlight creates a steady, unidirectional stream of raw DC, or direct current electricity. We've got power. But there's a catch. How does this raw power run your TV? Well, the truth is, it can't. If you somehow plugged your appliances directly into a solar panel on your roof, literally nothing would happen. This energy needs a translator. That brings us to part 4, inverters, DC to AC. Enter the inverter. This is the vital mechanical solution in our journey. It's the device that translates that raw DC electricity into usable AC electricity by rhythmically alternating the current back and forth. This brilliantly illustrates the big shift. The inverter bridges the gap between DC electricity, the direct current flowing straight out of those solar cells, and AC electricity, which is the alternating current your house actually needs to function. And finally, part 5, powering homes and grids. We're pulling back to the macro view now. The transformation is complete. We finally have that fully regulated AC electricity, completely safe and absolutely ready to power every single plug in your house. This power flows instantly right to homes and household appliances. And the coolest part? Any excess AC electricity you don't use doesn't just disappear. It's immediately sent back out, silently supporting the wider electrical grid and helping your whole community. So, it leaves us with a pretty wild thought. With sunlight silently powering our homes every single day, what other invisible forces could we harness next? Thanks for tuning into this explainer, you guys. Keep learning and keep looking up.